Okay, number 59 has got an electric immersion water heater. Um, so you have your water here, and then this thing goes in, and they say it's 300 watts. Now, the thing to know about a watt is, if you look in the back, the definition of a watt is a joule per second. So this thing is giving heat to the surroundings at a rate of 300 joules per second. So what we're going to do with this problem is figure out, number one, how much heat does it take to raise, how much heat it takes for the glass, and then how much heat it takes for the water. And so I'll figure out how many joules it takes for me to raise the temperature of the glass up to 100, and how many joules it takes for me to raise the temperature of the water up to 100. And then that'll give me a certain number of joules. And I get 300 every second, so I just figure out how many 300s is that. That's how many seconds, and I'm good to go. So MC delta T for water, MC delta T for glass. The mass of the water in this thing is, let's see here, 0.25. The specific heat, 4180. And the change in temperature, it goes from 15 up to boiling, so that's 85. So 0.25 times 4180 times 85. I get 88825 joules. Now for the glass, the mass of the glass is 0.3. The specific heat of glass is 840. And the change in temperature is also 85. So 0.3 times 840 times 85 is 21420 joules. So my total amount of heat is, add them together, and I get 110245 joules. That's how many joules it takes for me to raise the temperature of this stuff. So what I do, I'm getting 300 joules every second. So you could set up a proportion. I get 300 joules every 1 second, 110245 joules in X amount of seconds. So I could cross multiply and divide. So I take this divided by 300, and I get 367 seconds. So I could divide that by 60 again, and I get 6.1 minutes. And that's what your book has, 6.1.